Hi, and welcome to Math BJC Lessons. So happy to have you today. This is the second in our series for algebra, and we will be continuing with simplifying expression. And I believe that by the end of this series, you too will love algebra. Yay! All right, let's look at our objectives for the day. By the end of this lesson, you will be able to simplify algebraic expressions by multiplying algebraic terms. But first, a little review. Algebraic expressions. So we got to go over some of the vocabulary that you will be hearing during this lesson, and we introduced most of these last week. So an algebraic expression is a mathematical phrase usually combining numbers and or variables using operations. Now, these are the parts. So a lot of the vocabulary really was right there in the definition. We have coefficient, and the coefficient is a number, but it's a number that's multiplying a variable. So whenever you see a number looking like it's attached to a variable, that's a coefficient. So what's the variable? The variable is a symbol, usually a letter. For our exercises in BJC, our variables will be letters. So our coefficient is 7. Our variable in this here is n. Our operation in this expression is addition. There are 4 basic operations that you would have been accustomed to from primary school: addition, subtraction, multiplication, and division. All right, we are going to be using another operation, but we're going to get into that a little bit more. Then we have the constant. The constant, as its name implies, is something that doesn't change. It's a number that stands alone. So 2 will always just be 2, which is good to know. Now, these here, the 7n and the 2, they are what we would call terms. And for collecting like terms, however you're doing it, this is going to be important. All right, so your terms can be the number by itself, the constant by itself. It can be a variable by itself. It can be a combination of a coefficient and the variable. Those are terms. However, the moment we add that addition or subtraction operation, the moment we do that, at that point, we now have an expression. All right. So these videos, if you did miss the first video and you get a chance to go online, please do go and check out the Bahamas Virtual Learning site, because these lessons are uploaded there already for you to review along with additional exercises. Another word that we did not have last week, but we will be seeing in this lesson, would be exponents, otherwise known as powers. These are going to be, so an exponent will be, first of all, a numeral. Inside this lesson, an exponent will be a numeral. That's number 1. Number 2, it will be written on the upper right hand of the number. And number 3, the job of the exponent is to show how many times the number is to be used as a factor. So it's going to tell us how many times we're going to be using this number in a multiplication statement. Here's an example. We have 10 to the 3rd power, or 10 cubed. The exponent is 3. Notice the 3 is written in the upper right hand corner, or the upper right hand side of the 10. And so that means that we're going to use 10 as a factor 3 times in a mathematical statement. 10 times 10 times 10. All right, now we're ready to get into our lesson for the day. Let's start with something familiar to you. In primary school, you would have learned that 3 times 4, which is also 12, literally means 3 groups of 4. I'm going to say that again because really and truly, the majority of what we're doing today is going to be so easy and so simple. I just want you to clear your mind a little bit, get back to the basics. 3 times 4, 3 groups of 4. Are you with me? I know you are. So when I show you 3 times B, well, 3 times B would mean, well, 3 groups of B. So we have B, 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 3B. Look at it, let it soak in. I hope you have paper and pen and you are writing. Yes, it really is this easy. 3 times B, 3B. All right, now let's look at this. If 3 times B is 3B, then A times B, AB. And A times B times C is equal to ABC. It's almost like magic, but no, it's even better. It's math. So what we have, if you notice, what happened between the question and the answer, that product? Do you notice what happened when we multiplied those variables together? A times B equals AB. A times B times C equals ABC. Yeah, we just moved the multiplication sign. I know math gets a bad rap, but really and truly, math was invented and is continually invented to help us solve problems and represent things that exist in the real world. So I believe by the end of this series, you're going to be loving math a whole lot more. Let's continue. Let's try something. I'm just going to throw it out to you. What do you think is X times Y? If you said XY, you are correct. All right, we're going to use our knowledge from primary school, 3 times 4 equals 12, to do one more algebraic expression. We're going to simplify one more. All right, 3 times 4B. Well, 3 times 4B, that means 3 groups of 4B. And you can see it on the screen. I have 1 group, 2 groups, 3 groups. Ta-da! 3 times 4B equals 12B. And if you were thinking the way we were thinking in our first lesson, 3 groups of 4 bananas is 12 bananas. 3 groups of 4B, 12B. All right, let's continue. Now we come to exponents. And I believe in the first semester, you would have gone over square numbers and cube numbers. And I know in my class, sometimes I do this little thing. 1 squared is 1, because 1 times 1 is 1. What? 2 squared is 4, because 2 times 2 is 4. All right, but these are exponents, right? So 3 squared equals 3 times 3. And then we got 1 cube, or 1 raised to the 3rd power. That's 1 times 1 times 1. And 2 cubed is 2 times 2 times 2. So you see the pattern. Now, suppose I turned it around. And I said, well, what do you think is 6 times 6 in exponent form? 6 times 6 is 6 squared. And P times P is P squared. Let's look at that third one. P cubed. P times P times P. So you see it? There you go. And believe it or not, we are almost down to the last step that you actually need for algebraic multiplication. After this, the world is yours. Once you have a good foundation, you're good to go. All right, here is an example. P cubed times P squared, or P to the third power times P to the second power. Well, first off, here's what I need you to remember. P cubed, we can expand that as P times P. And P squared, we can expand that to P times P. So really and truly, when you look at it, we just have 5 P's there, right? But they are connected by multiplication. And this is important. So we put P to the 5th power. All right? Got it down? Excellent. Let's look at another one. We have Z squared, or Z to the 2nd power, times Z to the 4th power. So we're calculating the product of Z squared and Z to the 4th power. What do you think is the first thing you need to consider? Well, Z squared, that's your Z times Z, and I tried to color code to help you make the connections. So Z squared is in that hot pink. I'm feeling the summer coming. And then you have Z times Z. And then we have Z to the 4th power. And of course, we have our 4 Z's there with multiplication. Now, how many Z's would that be in that mathematical statement connected purely by multiplication? Z to the 6th power. Now, if you look at those exponents, you're going to see a pattern. You're going to notice. Let's look at that first one, where we have P to the 3rd power times P squared. Well, right here, the exponent is 3. The exponent is 2. The resulting exponent is 5. How did that happen? Let's look at the next one. This first exponent is 2. The second exponent is 4. And the resulting exponent is 6. How did we use 2 and 4 to get 6? If you said add, you are absolutely correct. So down here at the bottom, we got a little here bit of a tip for you to help you so you do not have to keep on writing out those variables. To multiply variables, add the exponents. I'm going to say it again. To multiply variables, add the exponents. And there's just one little side note that you're going to need to keep in your back pocket. If you do not see an exponent on a variable, it's 1. And it's not a secret, so you can feel free to tell anybody and everybody. If you do not see an exponent on a variable, the exponent is 1. All right, let's have some fun. Let's see how well we can put all of these things together. Multiplying algebraic terms. So, step 1, we're going to multiply the coefficients. Remember those coefficients, the numbers that look like they're attached to variables, right? Those coefficients. We know that that's already a multiplication in process, but that's going to be step 1. We're going to identify our coefficients and we're going to multiply them. Then step 2, we're going to multiply the variables. Let's jump in. Woo! All right. Example 1, 3pq to the 3rd power times 4qr. So step 1, we're going to multiply the coefficients. What are the coefficients? 3 and 4. Excellent. Then we're going to start looking at our variables. The first variable, and we usually pull these in alphabetical order. Please remember that. Our variables are usually expressed in alphabetical orders whenever we are calculating products. So P, and there's only one P. That was easy. What's the next variable? Q. And we have two sets of Q's there. We have Q to the third power, and then we have that Q all by its lonesome self in the second factor. Do you remember what the coefficient is when you don't see any? 1. Excellent. We have one more variable, R. Now let's put it together. We have our 3 times 4, which is going to give us 12. The P is still there, that's fine. We have Q to the third power times Q, and remember, it has that hidden exponent there. I usually say it's invisible, but let's keep going. So we have Q to the third power times Q. That's going to give us Q to the fourth power. And the R was all by its lonesome self, still there, the only R, representing, yeah, R. All right, so looking at that, making sure, and hoping you like colors the way I like colors to help you make those connections. So 3 times 4 is 12. That P is just coming down as P. Our Q to the third power times Q is Q to the fourth power. And then we have our R. Our final answer is at the top here. For those persons who might not have noticed, our final answer is 12P Q to the fourth power R. Because remember, when we're writing our final products, we do not use multiplication signs. All righty. Now, example number 2. We have negative 2a cubed b times 3ab squared c. Now, I know that for a lot of us, integers and negatives are, but it's okay. We go one step at a time, and I promise you, you're going to do well. So let's start. Our first step is we're going to look for the numerical coefficients. So our first numerical coefficient is negative 2. Our second coefficient is 3. So we're looking at negative 2 times 3. Well, you know 2 times 3 is 6. You know that. So negative 2 times 3. Put that right in the side there. I want you to start thinking that negative 2 times 3. But we're just pulling out stuff now. Then we have our a cubed from the first factor times a. See that a there? Good. And when we don't see an exponent, what is the exponent on this variable? 1. Exactly. You got to remember that when you don't see it, the 1 likes to be invisible. We digress. Let's continue on. I'm having fun. Then we have B, because we are continuing in alphabetical order. So we have B times B squared, right there. And then we have one more variable, which is C. Excellent. So we have actually collected our like variables, so to speak, okay? Not like terms, but we collected our coefficients together and we collected our variables together. It's a little bit different, right? So now let's go and calculate our answers. Negative 2 times 3 is negative 6. A cubed times A. So A to the third power times A. And remember there's that invisible 1 that's right there. So when we're multiplying our variables, they're adding our exponents. So 3 plus 1 is, we have A to the fourth power. And then B times B squared. All right. So let me just put this in right here. You know, you're going to have to please excuse my writing. So we have our A, because I just want to make sure everybody is with us. That's A to the third power plus, remember what we said, if you don't see an exponent, it's going to be 1. So that's 3 plus 1. That's our a to the 4th power. I want to make sure everybody is with us. And then here we have our b. What's the exponent on this first b? I don't see anything. What could it be? Wink, wink. All right, it's going to be 1, right? And right here, our second exponent, or our exponent on that second b, is going to be 2. So we have 1 plus 2. Good? All right. So we have our next. So we have -2 times 3 is -6. We have a to the 3rd power times a is a to the 4th power. And then we have our b times b squared, which is b cubed. And finally, right here, bringing up the rear, but just as important is our c. This is our final answer. All righty. Now, let's get some practice in. Yes, I believe you are ready. You are ready. Just gonna clean up my board a little bit here. Okay. All right, so you're ready. What is step 1? What's the first thing you're going to do? And what is the second thing you're going to do? Well, let's do this. The first thing we're going to do is we're going to multiply our coefficients. So we have 2 and 4. 2 times 4 is 8. Listen, you are halfway there in question number 1. If you got 8, second part, you're going to multiply the variables. So what are your variables? A and B. So A times B. Do you remember? I hope so, and I hope you wrote it down. AB. So our final answer is 8AB. 2 times 4, 8. A times B, AB. All right. Ooh, this one has 4 terms. But this doesn't scare us at all because we know it's really just 2 steps. First, we're going to multiply our coefficients. There they are, 4, 6, and 2. So 4 times 6, 24. Good. 24 times 2, 48. Good. Now, next step. We got 2 variables in there. So we have our t's first. Ooh, look at those t's by themselves. T times t, t squared. And then one more set of variables, u and u. U and u. U times u, u squared. This gives us our final answer, 48 t squared, u squared. All righty. Now, let's go. Because I really like to work with you, we have you again. I know I can do some really corny jokes, but I love it. So I'm working so happy to be working with you again. 3u times 3u times 3c. What is step 1? I'm gonna give you about 3, 4, 5 seconds to do this. All right, so we have 3 times 3 times 3. 3 times 3 is 9, and 9 times 3 is 27. Good. Then we're going to look at our variables. I'm sure you see 2 variables there, 2 distinct variables. But remember, we want to proceed kind of in alphabetical order, right? So we're going to go with our C first. And the C is just by itself. So we just like, we got that. All right, one more thing. What is it going to be? What will be our next set of variables? All right, u times u. U times U squared. So our final answer, 27 CU squared. All righty. I hope you're taking these down. And a good way to practice is, especially with these questions that we are doing together, is you can write the questions by themselves on a piece of paper and try to work them out. It's always good if you can go over things within 24 hours after learning them. It really helps it to stick, okay? All righty. There we go. Number 4. And we're just simplifying algebraic expressions. It sounds really complicated, but really and truly, when you look at it, the way we're doing it, it's really simple. We're taking one step at a time. All right. That was me stalling so you can write down the question. We begin by multiplying the coefficients. So what are the coefficients? The numerical coefficients. All right. So 3 times 5, 15. Excellent. So I didn't pull it down because after a while we can tend to move through things a little bit faster, but I'm still color coding. Then what would be our variable? Which variable are we going to work with first? Yay, we're going to work with m. So m times m squared. And again, what is the exponent on that first m? What is that exponent? If you said 1, you are absolutely correct. So just a reminder here, little side note, this here is m, and we don't see an exponent. We know that 1 is right there, but it's invisible. We don't see it, but we know it's there. All right, and when we're multiplying our variables, we add our exponents. So we have m to the 3rd power. Good. All right, now I'm going to erase that while you work out the final thing that needs to happen. Okay, I know you're ready for me, so let's go. Sorry, right here. So we have n to the 4th power times n squared, and multiplying our variables, we add our exponents. So 4 plus 2, n to the 6th power. Our final answer, 15m cubed, n to the 6th power. Do you remember how we got the 15? Do you see how we got that m to the 3rd power? Do you remember? Do you understand? I want you to make sure. Do not let it throw you off, one step at a time. Make sure you know. This is how we got the 15. Tell me, how did we get the 15? Say it aloud. 3 times 5. How did we get that m to the 3rd power, or m cubed? Right, we did m times m squared. We add the exponents together. How did we get n to the 6th power? We had that n to the 4th power times n squared, and we added the exponents together. Yes, you are becoming a boss in mathematics. Practice question number 5. This is our last practice question like this. Simplifying algebraic expressions using multiplication. I'm excited for you. So, step 1. Giving you a chance to write the question down and to do step 1. What do you think is the first thing we're supposed to do? What do you think is going to be the first thing that I write down? Alrighty. 6 times 3. We're multiplying our numerical coefficients. A numerical coefficient just means coefficients that are numbers. Okay, so don't let the big words fool you. I want you to get used to the vocabulary of mathematics. So those are our numerical coefficients. When you're explaining this to your parents or to your peers, yes, use the vocabulary. Let them know that you're multiplying the numerical coefficients. So we have 6 times 3, which is 18. All right, this is our second step. M cubed times M squared, M to the 5th power. All righty, gonna give you like 5 seconds to do the very next thing. Very next thing. What do you think we're gonna do next? All right, we have n to the 4th power times n squared, and that's n to the 6th power. We have one more thing and we are finished. One more thing and we are finished. I know you can do this. What is the final thing that needs to be done? I can't hear you. You gotta say it. You really gotta say it. Those of you who said P times P squared, you're correct. That is the final thing. P times P squared. Our answer for question practice number 5 is 18. M to the 5th power, N to the 6th power, P cubed. That is the correct product. All right. Now, we have reached the conclusion of our lesson, but don't run because I have a special something for you following this. But let's consider if the objectives of the lesson were met. How far? How much? How well can you simplify algebraic expressions by multiplying algebraic terms? Now I know, yesterday that might have seemed like a whole lot, all those words inside there, but now I know that you have a better understanding. But we're gonna look at it still. Are you at step 1, where you say, you know what, I can calculate the product of numbers. I can do 4 times 5. And that is actually the first step in simplifying algebraic expressions. So if you can do that, that is good. I mean, you're off to a good start. You have a good foundation. Now let's go. Second thing. You can calculate the product of simple algebraic terms. So if somebody asks you, what is the product of 4 and b? What is 4 times b? You would know 4b. You'd be like, duh. You wouldn't say that now, but you would think. You'd be like, oh, that's easy. We did that. If they ask you d times e, you're like, piece of cake, that's DE. And if you found yourself understanding the questions that we did just now in practice, you might have made a mistake because you're human, yes? But you understood what we did, you understood your solutions, and even when you made your mistakes, you were able to see this is where I made my mistakes. That is excellent. The objectives for this lesson were the objectives were achieved. You are going to need to practice because that's how math is. Practice makes perfect. So one little though reminder up at the top, there are some things that you do want to take into consideration, and these will enhance you as a student. You want to be a creative thinker. You want to be an effective participator. And although it might seem as if you are on the other side of the screen from myself, you know what? When you're writing, when you're talking, you're answering, you are participating. You want to be an independent inquirer, right? Being able to ask those important questions. When you don't understand, don't be afraid to ask. You want to be a reflective learner. You want to think back. Go over this within 24 hours, please. Self-manager. Manage your time wisely. Thank you that you came to spend this time. And then you want to be a team worker. So if you do have contact with your teacher in your school, please do reach out to them. Shoot them some of your work. Ask questions. Keep on trying. If you have peers who are also working with you, classmates who are working, encourage them. The more of us that are on board, the better it will be. Now, a little special something. We're gonna do a review because these are BJC lessons. We're gonna try to be building some review into these. All right. Now we have 5 questions, and then we have an extension, just a little something extra. And I actually want us to start with the extension. So we're going to start at the bottom and move our way up. Okay. Our extension, we want to express 20 as a product of prime factors. And just as a hint, because I know for some of us it's been a while, you can use the factor tree. That's what I'll be using. But you can also use the division ladder. So whichever one you used, you mastered already, please feel free. Okay. And for those persons who it's still a little bit foggy, there's this thing that I do with prime numbers. So it's like prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, right? Just a little thing. You gotta, those of you who like music, like myself, find ways to add a little fun with music to those things that you need to recall very quickly. Prime numbers would be one of those things that it would be really helpful for you to be able to recall. 2, 3, 5, 7. Those are your first 4 prime numbers. All right, let's do this. So 20. First off, before we look for prime factors, we're just going to look for factors. All right, so 2 numbers that will multiply together to give us 20, 10, and 2. All righty. Now remember when we were doing those prime factors just now, these are prime numbers. The first one I said was 2. All right, so that 2 is a prime number. We can't break that down no more. But that 10, that's a composite number. We can break that down. 2 numbers that multiply together to give us 10. What are 2 factors? 5 and 2, because 5 times 2 is 10. And 5 is a prime number, 2 is a prime number. This is all working using the factor tree. And these are our prime factors for 20. Our final answer, 20 is equal to 2 times 2 times 5. We can also write this in exponent or index form. So that index form that's related to that exponent, which we have been doing all lesson. So that's going to be 2 to the second power times 5. All right. Now let's go to question number 5. Question number 5, right here. Do you remember what that symbol means? That is our square root symbol. It looks like division, but it's not. It got a little extra something there. So that's the square root of 25. Do you remember how that works? Well, for these 5 questions, I'm going to use what I like to call a thinking bubble. So it's showing you what is going on in my brain. And a lot of times I feel that it is necessary for us to write our thoughts on paper. So here we go. This is my thinking bubble. 5 times 5 is 25. If 5 times 5 is 25, then the square root of 25 is 5. Take it down. If you don't have it, please feel free to take it down. All right, we're going to question number 4, which I know is going to be a piece of cake after the lesson we just had, because we got exponents again. 8 squared. So 8 squared, and we're going to go back to our thinking bubble. 8 times 8. Because the exponent is telling us to use 8 as a factor 2 times inside our multiplication question. So 8 times 8, and the answer is 64. Working our way. Write the LCM of 2 and 5. LCM of 2 and 5. Well, what does LCM stand for? Lowest common multiple. Well, I believe we kind of know what low means, but just in case you think it means something different in mathematics, it really is going to be the smallest, okay, of whatever we're looking at. And then we're looking at common or something that's the same. Then we're looking at multiples. So multiples of 2. And we are going to be exploring in future lessons other ways that we can calculate things like LCM and HCF, but because this is the first time we're doing a review, we're going to keep it quite basic. So our multiples of 2, 4, 6, 8, 10, 12. Yes, that's what we're talking about, our multiples of 2. All right. And then we have 5, multiples of 5, right? Come on, let's get some multiples. Lots and lots of multiples. 5, 10, 15, 20, 25. Those are multiples of 5. I'm so excited. You have to excuse me. I'm excited because I know that some of you are just amazed at how easy this math really is. And I believe that you're finding it even a little bit enjoyable. So I'm looking forward to you coming back for the next lesson. All right, so we have some multiples of 2, we have some multiples of 5, but we're going to look for what's common, what's the same. And right here, we have 10. And we don't have anything else in common that is smaller than 10. So our lowest common multiple, okay, and I have something there that needs to change. So we're going to fix that quickly. Yes, we're going to do that. That's a 64, but that ain't for that, right? That was for our other answer. There we go. So we're going to write that over there, fix that. Our LCM is going to be 10, all right? So let's just put that right there. Boom. There we go. LCM is 10. Now, almost finished. 2 more questions. So we have the HCF of 16 and 12. This would be highest common factors. Now to do this, the first thing I want you to think about would be the factors of 16. And first one out the gate will be 1 times 16. A lot of times we take it for granted and we forget the 1. But the first pair I want you to think about, 1 times 16, 1 times the number. Then we have 2 times 8, 4 times 4. Factors of 12. What do you think will be the first pair of factors that I am going to write down? Dun, 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 dun. 1 times 12, then 2 times 6, 3 times 4. I will not write down 4 times 3 after this because 4 is already there and 3 is already there. I won't write down 6 times 2 on that same line because 6 is already there and 2 is already there. So this is how we find factors. But we have found that it is so much easier to organize our factors. So what we're going to do is we're going to arrange them in ascending order without the multiplication signs. We're going to arrange them. Now that we know what our factors are, we're going to arrange them in order. So we have 1, 2, 4, 8, 16. Those are the factors of 16. And then for 12, we have 1, 2. I have a number missing. Can you tell me what the number is that is missing? The number is 3. I have a 3 that is missing. Let's put that 3 in right now. Okay, so let's put this right here. My 3 would have gone right up in here because I'd have been putting them in order. Right there. Okay, good to go. Now that we have our factors listed, and I can double check, I got my 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. For the 16, I have 1 times 16. If you can follow my spotlight, 2 times 8 is 16, and 4 times 4 is 16. Good. So now, what do they have the same? Okay, let's look. They have 1. Both of them have 1 in common. What else? Both of them have 2 in common. And finally, both of them have 4 in common. So we have 3 factors that are common. What is the highest of those 3 factors? Your answer is 4. So the HCF of 16 and 12 is 4. And like I said with the LCM, in upcoming lessons, we will be reviewing other methods for calculating HCF and LCM that you will be needing for your BJC exam. But we are down to the final question. Round 6.81 to 1 decimal place. Round 6.81 to 1 decimal place. All righty. So the first thing you need to figure out is, well, what is 1 decimal place? 1 decimal place is literally 1 digit behind the decimal point. So 6.81, which digit is going to be the first one behind the decimal point? 8. So 8 is the digit that is on the stack. That is 1 decimal place right there. And we are rounding, and we usually would say round off, because at that, for this, especially with decimal numbers, we are really going to be cutting things off. Cutting stuff off, yeah. Know how that sounds, but it's true. We got to do this. So 8. The 8 is the number that is highlighted right now in the spotlight. But I say all the time, math is like life. I believe it. And so for every time you see someone on stage, there's someone behind the scenes calling the shots. So the 8 might be on the stage, but the 1, the digit behind it, is actually calling the shots. So the 1 is going to tell this 8 what to do. And anytime you have 0, 1, 2, 3, 4, anytime you have those small digits, those small numbers talking, they're going to tell you, look, stay the same. Don't go nowhere. Stay right here. Don't go. All righty. So that 1 is, don't you do anything. So our answer, believe it or not, is 6.8. That's our answer, 6.8. So I'm gonna just take this right here because I do a little something extra. So I'm just gonna fix that because I want y'all to have the correct answers. So right there. All right. So your final answer is 6.8. This is the end of our lesson, Math BJC. Thank you so very much for joining me today. And once again, don't forget, pass the word along, encourage others to join in, and I look forward to seeing you again here with Math BJC.